Okay, let's look at anti-differentiating using linear substitution for the general rule. So this is what we did in class the other day, but just to work our way through them. First thing I would do is let u equal cx plus d, because that's the one that's inside the bracket or the one with the power. So that means du dx is c. Also, we need to find x in terms of u. So from here, x would equal u minus d over c. So when it comes to rewriting, we're going to have a outside of u minus d over c plus b, that's what the first bracket is. Then we're going to have u to the power of n, and then we need to bring du dx in. Now du dx is worth c, so we'll bring in 1 on c du dx times the dx that's already there. Because of this function here, okay, we need to make sure that we tidy this up. So we're going to do like the lowest common denominator. So we're going to have a bracket u minus d plus bc all over c. That comes from cross multiplying here because b really is sitting on 1. So there's the first bracket. Then you've got u to the n. Then you've got 1 over c. And then you've got du because the dx's have wiped each other out. So that means we have c here and c here, and they're multiplied together, so we can bring them out the front. So it's 1 on c squared outside of au minus ad plus bc in one bracket u to the power of n du. So we get 1 on c squared. What I'm going to do here is you've got a times u, and then I'm going to put bc minus ad together in like a little bracket, and then you've got your big bracket u to the power of n du. The reason for that is that's already got a u term in it, but this together is actually just a constant value. Okay. So what have we got? We've got 1 on c squared, we've got integral, we had au plus bc minus ad, and all of that was multiplied by un du. So, expanding, we now have 1 over c squared integral. If you open up this, you multiply these two together, so it becomes au to the n plus 1, plus, then you have bc minus ad, which is just really a constant value multiplied by u to the n. And you wish to anti-differentiate all this. So 1 on c squared outside of au. Add 1 to the power here, that becomes n plus 2, and you divide by the power, so it's n plus 2. Plus, you have this whole constant bc minus ad, u, and you add 1 to the power, so it's un plus 1, and you divide by the new power, which is n plus 1, plus let's call it k for a constant. So if you wish, you can write the general rule like this: a cx plus d to the n plus 2 over c squared n plus 2 plus bc minus ad times cx plus d to the n plus 1 over c squared n plus 1. So if you wish, and you had that formula stated on your formula sheet, you could simply substitute values and solve.